This is AP Calculus 3.1, continued. We're still going to be working with the chain rule. In this section, we're going to put some chain rule operations together to make sure you understand how the product rule, the quotient rule, and the chain rule can all work together in the same problems. So we're just going to do some examples here. The directions for all of these are going to be to find the derivative of the given function. So if you look at the first one, here we have y equals cosine 3x squared times cosine to the fourth x. We're going to use the product rule here because we have two functions multiplied together. So remember, in the product rule, you have to take the derivative of the first times the original second plus the original first times the derivative of the second, and then you would simplify anything that you have left if you can simplify. So to take the derivative of the first thing here, we know that the derivative of cosine is negative sine. We keep the angle part, 3x squared. And then to complete that derivative, the chain rule says we have to take the derivative of the angle part, or the inside part. So that would be 6x. And then we have to multiply by the original second. So that would be cosine to the fourth x. And then we have to add that to the original first, cosine 3x squared, times the derivative of the second part. Now, the derivative of this part, that is the chain rule. This is cosine x to the fourth power. So 4 times 1 would be 4. We decrease the power, that's cosine cubed x. And then we have to take the derivative of the cosine x, which would be a negative sine x. The derivative of the x part is just 1, so that's not going to change anything. Then I need to simplify this. In this, I need to multiply anything that I can multiply together. So looking at this part right here, it might be tempting to try to multiply the 3x squared times the 6x, but remember that 3x squared has to stay with the sine because that's the angle part. I've seen that done before. You have to leave that with the sine. So there's really nothing in the first section here that can be added together or simplified in that term. For this term, what I would do there is, let's see, we've got the cosine, that x goes with the cosine cubed. It has to stay there. That x has to stay here. So the only thing I see here that needs to move is that 4 really needs to go to the front. So that's minus 4 cosine 3x squared times cosine cubed x times sine x. And it's probably a good idea to put all that stuff in parentheses. And I could bring this down, negative 6x sine 3x squared cosine 4x. And then, we could look and see if they have anything in common, and it doesn't look like they do. So I think that for that one is all we can do. I could take out a 2, but that's really not going to help us any. That's just going to make it more complicated. For the next problem, if you notice, I've got something on top and something on bottom. I'm going to use the quotient rule with that. And remember, to use the quotient rule, you take the derivative of the top times the original bottom minus the original top times the derivative of the bottom, and that would be using the chain rule there. And then you put that over the bottom squared. So if I find y prime, the derivative of the top, derivative of sine, is cosine. I keep the angle part, then I take the derivative of the angle part, which would just be 1, so that's not going to affect anything. And then I multiply that times the original bottom. Well, I'm going to put that in the front because I don't want to get that confused with the angle part of my trig function. So I'm going to tag that in the front. Then I have to have a subtraction. I'm going to write down the original first part, which would be sine x plus 2. And then I'm going to multiply that by the derivative of this part. Now, the derivative of this, if I rewrite that as x squared plus 2 to the 1/2. Now, remember, we don't need to write it to a negative 1/2. We're not putting it on top. We're using the quotient rule. So if I write this out as it is, it's just going to be a positive 1/2 power. And then to take the derivative of this, I use the chain rule. So that would be 1/2 times x squared plus 2 to the negative 1/2 times the derivative of the inside part. So that would be 2x. So that, whatever I get for this when I simplify, is going to go right here. So now, 1/2 times 2, that cancels. So we have an x over top of the x squared plus 2 to the 1/2. So that is going to go on the bottom as the square root of x squared plus 2, because that's a negative 1/2. It has to go to the bottom of that term. And then don't forget, we have to divide by the bottom squared. Well, if I square that, that's just x squared plus 2. So now, I'm not allowed to leave this as is because this is a complex fraction. I have, in the numerator, I have a fraction. And so I can't have a fraction within a fraction. So I'm going to have to simplify that. The easiest thing to do, I think, would be to get a common denominator here. So what this term right here needs a square root of x squared plus 2 on the bottom. So if I put it on the bottom, doesn't that mean I'm going to multiply here by the square root of x squared plus 2? So if I do that, what happens here is the square root just cancels because they're the same thing under the square root. So I've got y prime equals x squared plus 2, because the square roots cancel, times cosine x plus 2 minus x sine x plus 2, and that is all over that denominator, square root of x squared plus 2. Now, this is my numerator all added together. That is still over top of the x squared plus 2. But if you know much about a fraction over a fraction, if I'm going to divide the top fraction by the bottom fraction, isn't that the same thing as x squared plus 2 over 1? So to divide by this fraction, that means I have to invert and multiply it. So I'm going to multiply by 1 over x squared plus 2. And so then I'm going to continue this over to the side. So if I rewrite this, if you look at what you've got y prime, and I've got to keep the numerator the same. All it's doing is multiplying by 1. So I've got x squared plus 2 times cosine x plus 2 minus x sine x plus 2 all over, now x squared plus 2 times the square root of x squared plus 2. Well, this is x squared plus 2 to the 1/2 power. This is x squared plus 2 to the 1 power. So if I add 1/2 plus 1, that's 3/2. So I have x squared plus 2 to the 3/2 power. It's tempting here to try to cancel out the x squared plus 2 with that, but unless it shows up in each of these terms, you can't do that. You could try to distribute something out and see if something would cancel, but for this problem, that's really all I can do. I can't cancel anything out. I've got it simplified the best that I can, so there's really nothing else I can do with that one. That one's got a really complicated answer. In this one, doing the same thing, finding the derivative. Notice it's got a negative in front, so that's understood to be multiplied by -1. So I'm going to bring that -1 down as part of my answer. So I have the negative. And then remember, the derivative of cosine is negative sine. So if I do a negative, that's minus a negative sine of negative x. So that's going to end up being a plus. And then I have to take the derivative of the angle part, which ends up being a -1. So if I got plus a -1 sine negative x, the answer there would be negative sine of negative x. And that's all I can do with that. That one's tricky because of all of the negative signs and having to cancel each other out and put another one in. So you have to be real careful with your signs for your trig functions as well. The purpose of doing this is really to recognize when you have the product rule, when you have the quotient rule, when you have the chain rule, and when you have a combination of all of them. So if you look at this one, now think about that. Before I do it, I want you to think about, what would you use for this? Product rule? Quotient rule? What's not quotient rule? We don't have a quotient. Chain rule? When I see this problem, I see two things. I see that this function is multiplied by this function, so that tells me we have a product rule. And then I also notice that this right here is the chain rule because it's got a power of 3. And this is a chain rule for a simple trig function because of the angle part not just being x. So we have the product rule combined with the chain rule here. So I'm going to do it just a step at a time. F prime of x. Well, I'm going to deal with product rule first. I have to take the derivative of the first part. Well, that's the chain rule. So that's 3 times 3x squared minus 2 squared times the derivative of the inside part, which is 6x.